Beneath the Bismarck Sea was something enormous has been stirring for more than 2 months. And this weekend, it announced itself. A magnitude 6.4 earthquake struck the ocean floor beside an eruption almost no one has seen because it is unfolding entirely underwater. It is the most powerful volcanic eruption on the planet right now. Stay with me and you will learn why scientists just doubled the count of hidden undersea volcanoes and what it means that Earth's largest volcanic system is the one we notice last. The largest volcanic eruption on the planet right now is one that almost nobody has seen. It is happening on the floor of the Bismarck Sea, about 130 kilometers southeast of Manus Island in Papua New Guinea, and it has been going for more than 2 months. It started on the 8th of May, 2026, along a submarine feature called Titan Ridge, and as of today, it shows no sign of stopping. There are no dramatic photographs of a mountain tearing itself apart, because the entire event is unfolding beneath the sea, out of sight of every camera on the surface, and yet it has pushed steam and ash into the sky, stained the water a sickly color for kilometers, and spun off floating rafts of volcanic rock large enough to see from orbit. Scientists first caught it not with their eyes, but with their instruments. At about 1:15 in the morning, Universal Time on the 8th of May, seismometers run by the Rabaul Volcano Observatory picked up the signature of magma forcing its way up through the crust under the Bismarck Sea. Within hours, a plume had broken the surface. The observatory identified at least 2 separate eruption centers on the ridge, roughly 2.5 kilometers apart, both active at once. This was not a small hiccup on the seafloor. This was, and still is, arguably the most powerful volcanic eruption anywhere on Earth in 2026. And it is playing out where we can barely watch it. The satellites have done most of the watching. Instruments including the European Sentinel-2 platform and the sensors feeding the NASA Earth Observatory have captured volcanic plumes rising off the water, thermal anomalies glowing on the surface, and enormous fields of floating pumice. One single raft of that floating rock, imaged by Sentinel-2, measured about 69 square kilometers. That is a slab of volcanic stone drifting on the open ocean with a larger footprint than the island of Manhattan. Steam and ash plumes have at times climbed to somewhere between 10,000 and 20,000 feet, high enough to matter for aviation, though not quite tall enough to punch into the stratosphere. The people of Manus province are already living with the consequences. In early June, those rafts of pumice drifted northwest and piled up along the coastlines of several islands, choking harbors and fouling the water. A former member of Parliament for Manus, Ron Knight, said the floating rock had begun killing the marine life that local communities depend on, smothering fish, coral, and seagrass. This is the part of an underwater eruption that people forget. It does not need to reach a city to hurt people. It can reach out across the sea and strangle the fishing grounds that a whole community lives on, all while the volcano itself stays hidden below the waves. The eruption is being tracked by a serious lineup of institutions. The Rabaul Volcano Observatory has the frontline seismic picture. The NASA Earth Observatory is watching from above. The German Ocean Research Center GEOMAR and the Smithsonian's Global Volcanism Program are both following the event. But here is the uncomfortable truth that runs underneath all of it. Even with all of that attention, we're still mostly guessing about the fine details, because there's a lot of water in the way. And this past weekend, the ocean reminded everyone just how restless this part of the planet has become. Yesterday, a magnitude 6.4 earthquake struck the central Bismarck Sea. According to the United States Geological Survey, it landed about 191 kilometers southeast of the town of Lorengau, which puts it within roughly 30 kilometers of the active eruption site at Titan Ridge. An earthquake of that size is not a footnote. It is a strong, clearly felt event, and its position right on top of an ongoing submarine eruption is exactly the kind of thing that makes volcanologists lean in and pay closer attention. It tells you the ground under that eruption is still moving, still adjusting, still under stress. That was not the only one. 2 days before the Bismarck Sea quake, another magnitude 6.4 earthquake struck the South Sandwich Islands region in the far South Atlantic on almost the opposite side of the planet. And the South Sandwich Islands are not just any patch of ocean. They sit on top of one of the most active submarine volcanic arcs on Earth, a place where one tectonic plate is grinding down beneath another and building a chain of undersea volcanoes in the process. So within a single weekend, 2 magnitude 6.4 earthquakes struck 2 of the most volcanically active underwater regions on the planet, thousands of kilometers apart. Both of these places share the same basic recipe. They are convergent boundaries, where one slab of the Earth's crust is being forced down beneath another, melting as it goes, and feeding a line of undersea volcanoes above it. The South Sandwich Arc, in particular, is one of the loneliest and least visited volcanic chains anywhere, a curve of submerged and half-submerged peaks in the storm-battered South Atlantic where hardly anyone is ever watching. When a magnitude 6.4 fires off there, it usually passes without a single human being feeling it. Now, a scientist will tell you, correctly, that two earthquakes on opposite sides of the world are almost certainly not connected. The Earth produces earthquakes of this size regularly, and our brains are wired to find patterns even where there are none. That caution is fair, but the reason these two quakes matter is not that they prove some global chain reaction. It is that they point our attention at the same overlooked truth from two directions at once. Most of the planet's volcanic and seismic action happens underwater, in places we hardly monitor, and every so often the seafloor sends up a signal loud enough for us to notice, which brings us to the discovery that reframes this entire story. In July of 2026, a team of researchers published something that should have made far bigger headlines than it did. They took an algorithm that was originally built to find impact craters on the surface of Mars, and they pointed it instead at maps of our own ocean floor. What it found was staggering. The algorithm identified 73 previously undocumented submarine calderas. A caldera is the enormous bowl-shaped scar left behind when a volcano erupts so violently that its emptied summit collapses inward. These are not small features. They are the fingerprints of the biggest eruptions a volcano can produce. To understand why 73 is such a shocking number, you have to know where we started. Before this survey, in the entire history of the science, only 78 submarine calderas had ever been cataloged anywhere on Earth. So a single study, using a repurposed Mars algorithm, more than doubled the number of these giant volcanic structures that humanity knows about. And it gets more humbling. Of those 73 newly detected calderas, only 5 had ever been independently confirmed before by any other method. The other 68 were essentially invisible to us until a piece of software trained on another planet went looking. The reason this is possible at all comes down to a simple, almost embarrassing fact about our planet. We have mapped Mars in finer detail than we have mapped our own seafloor. The oceans cover roughly 70% of Earth's surface, and the seafloor is the single largest volcanic province anywhere on the planet. Yet only a fraction of it has been surveyed at the resolution you would need to pick out an individual volcano. The raw figures vary depending on how you count, from under 5% mapped in real detail to about 25%, under the most generous modern estimates, but the conclusion is the same either way. The majority of the seafloor is, for practical purposes, unexplored. There could be hundreds, even thousands more of these calderas down there. We simply have not looked. Here is the fact that most people never learn in school. When you picture a volcano, you probably picture a cone on land, a Vesuvius or a Fuji or St. Helens, but those are the minority. The overwhelming majority of Earth's volcanism, measured both by the number of vents and by the sheer volume of rock erupted, happens underwater. It happens mostly along a single connected feature called the mid-ocean ridge system, a chain of undersea volcanic rifts that winds around the entire globe for roughly 65,000 kilometers. It is the longest mountain range on the planet, and it is almost entirely submerged. Every year it quietly produces more molten rock than every land volcano combined. So when we talk about the ocean-hiding volcanoes, we're not talking about a few odd exceptions. We're talking about the main event. The planet's volcanic engine runs mostly below sea level, in the one environment we are worst at observing. And the machine learning survey, coming in the same year as the Titan Ridge eruption and this weekend's earthquakes, forces an unsettling question. If we only just found 73 of these giant calderas by accident using borrowed software, how confident can we really be that we would notice if the whole system started ramping up? To answer that, we need to look at what the underwater record of the last 15 years actually shows. The recent history of undersea eruptions reads like a series of records that keep getting broken. Start in 2011 and 2012, when a volcano called Tagoro erupted off the island of El Hierro in the Canaries. It was the first Canary Island submarine eruption ever watched in real time with modern instruments, and it wrecked the local marine ecosystem for months. Then, in 2012, a volcano called Havre erupted north of New Zealand and produced a raft of floating pumice estimated at 400 square kilometers. That eruption was so far offshore and so completely underwater that nobody noticed it happening. We only realized it had occurred when satellites spotted the enormous field of floating rock. The pattern kept climbing. In 2015, axial seamount off the coast of Oregon became the first submarine volcano ever watched live, in real time, by a cabled observatory wired directly into the seafloor. Then, from 2018 into 2019, an eruption off the island of Mayotte in the Indian Ocean built an entirely new volcano out of about 5 cubic kilometers of lava, a fresh mountain roughly 820 meters tall rising from the seabed. It was the largest submarine eruption ever documented by direct observation, and it announced itself with an intense swarm of earthquakes, much like the ones we are seeing near Titan Ridge now. Each of these events, in turn, was called the biggest of its kind in years, and each one had its title taken away within a few years by the next. Then came the one that changed how scientists think about what an underwater volcano can do. In January of 2022, the Hunga Tonga volcano erupted, and it did something no eruption in modern memory had done. This was the event that proved the ocean is not just hiding volcanoes. It is hiding volcanoes capable of reaching up and touching the entire atmosphere. The Hunga Tonga eruption on the 15th of January 2022 was one of the most violent volcanic events in over a century. When it went off, it blasted an estimated 146 teragrams of water vapor up into the stratosphere, raising the total amount of water in that layer of the atmosphere by something on the order of 10% in a single stroke. Think about that. One underwater volcano measurably changed the chemistry of the global stratosphere. It also sent an atmospheric pressure wave racing outward that circled the entire planet multiple times and was recorded by weather instruments on every continent. It ranks among the largest eruptions since Mount Pinatubo in 1991. It also generated a tsunami that spread across the Pacific and produced some of the most intense volcanic lightning ever recorded, hundreds of thousands of flashes crackling around the plume as it rose. And it did all of that from a volcano that, just weeks earlier, most of the world had never heard of. That is the detail worth holding on to. Hunga Tonga was not a famous, closely watched giant. It was an obscure submarine volcano on a remote arc, exactly the sort of feature that hides in plain sight until the day it does not. The reason Hunga Tonga matters so much for this story is that it belongs to the exact same family of features that the Mars algorithm just counted by the dozen. It was a submarine and island volcano sitting on a poorly monitored arc, and it went from relatively quiet to globe-altering in a matter of hours. So when a survey suddenly reveals 73 more calderas we did not know existed, the natural next question is not academic. It is practical. How many of those are capable of a Hunga Tonga? We do not know, and we would not necessarily see it coming, because the same water that hides them from our cameras also muffles the small earthquakes that would normally warn us. That blind spot is not a hypothetical. It is a proven physical limit on what we can detect, and one place on Earth shows just how strange and violent this hidden world can be. Far to the north, under the Arctic Ocean, runs a feature called the Decoded Ridge. It is the slowest spreading segment of that global underwater mountain range, pulling apart at less than a centimeter a year. By every expectation, volcanism there should be sluggish and gentle. It is also buried under about 4 kilometers of seawater, and that much water presses down with such crushing force that explosive eruptions there should be flatly impossible. The weight of the ocean is supposed to smother any blast before it can happen. That was the textbook rule for decades. The Decoded Ridge broke that rule. When researchers investigated the site of a major earthquake swarm there, they pulled up fresh fragments of pyroclastic glass, the shattered, frothy rock that only forms in an explosive eruption from around 4,000 meters down. Something had exploded under 4 kilometers of ocean, where the pressure said nothing could. The explanation turned out to be chemistry. The magma feeding that ridge carried an extraordinary load of dissolved carbon dioxide, on the order of 10 times the amount found in normal sea floor lava. When that gas came out of solution, it expanded so violently that it blew the rock apart despite the immense pressure overhead. The lesson of the Decoded Ridge connects straight back to the center of today's story. It proves that the underwater volcanic system is not only larger than we assumed, it is also more violent and stranger than the rules once allowed. A place that should have been the quietest volcanic zone on the planet turned out to be capable of explosions physicists thought could not occur. So when 73 unknown calderas suddenly appear on the map, the honest response is not to shrug and assume they are all harmless. The one region we studied closely surprised us in the most dramatic way possible. And size, it turns out, is another thing the ocean is very good at hiding. Consider the case of Tamu Massif. It is a single volcanic structure sitting in the Northwest Pacific, and it is so enormous that for years scientists argued it might be the largest individual volcano on the entire planet. Its footprint covers an area comparable to the U.S. state of New Mexico, and roughly the same surface area as Olympus Mons, the giant volcano on Mars that is often called the biggest in the solar system. It rises about 4 kilometers off the sea floor, built from thick sheets of basalt laid down around 144 million years ago. It is a mountain of continental scale, And here is the part that should stop you. We did not properly recognize Tamu Massif for what it is until the 2010s. A volcanic construct the size of a U.S. state, comparable in area to the largest volcano on Mars, sat undetected on our own planet until barely a decade ago. Now, there is a genuine scientific debate about how to classify it. Later work, using magnetic data, argued that it was built more like a stretch of seafloor spreading ridge than a single central volcano, so calling it one giant volcano is contested, but nobody disputes its scale as a volcanic feature. Whatever label you put on it, it is a monument to how much the ocean can conceal. Tamu Massif closes the loop on the central question of this story. It is the clearest possible demonstration of why a survey can find 73 hidden calderas in one pass. If the ocean can hide something the size of New Mexico until the 2010s, then hiding 73 collapsed volcanic craters is nothing. The seafloor is not a well-mapped place with a few gaps. It is a barely charted world, and we are only now building the tools to see into it, which leaves us with the real question everyone actually wants answered. So is the planet's underwater volcanic system genuinely waking up right now? The honest scientific answer is that we cannot yet be sure, and the reason is important. Our record of these eruptions is extremely short and only recently equipped with good instruments. For most of history, an underwater eruption simply happened, unseen and uncounted. It is only in the last decade or so that we have had the satellites, the seafloor observatories, the pumice raft monitoring, and now the machine learning to catch these events at all. So the apparent surge, the run of record-breaking eruptions, and the sudden doubling of the caldera count might be exactly what it looks like from the other side. Not the ocean waking up, but us finally waking up to what was always there. That is the careful answer, and it is probably the most likely one. But it is not the whole answer, and this is the part worth sitting with. A record this short cannot rule out a genuine increase either. We do not have enough history to say with confidence that nothing is changing, and the system we are now, for the first time, able to watch is enormous, barely monitored, and, as the Gakkel Ridge and Hunga Tonga both proved, capable of far more violence than the textbooks once permitted. Whether the ocean is stirring or we are simply opening our eyes, the thing we are now looking at is bigger and more dangerous than most people ever realized. And before we look at what happens next, there is one claim about all this spreading online that deserves a straight answer. There is a theory circulating on the internet that the planet is quietly waking up, and that a global surge in ocean volcanism is being deliberately hidden from the public. It is worth addressing directly, because the honest response is also the more interesting one. The data is not hidden at all. The satellite imagery comes from the NASA Earth Observatory and is public. The earthquake listings come from the United States Geological Survey and are public. The volcano bulletins, the research papers, the seafloor maps, all of it is out in the open for anyone to read. These events feel hidden for a reason that has nothing to do with secrecy. They feel hidden because they happen under kilometers of water, where no camera can follow and where small warning quakes slip past our instruments. The obscurity is a matter of physics and ocean, not politics. Nobody is concealing the seafloor. The seafloor is simply very hard to see.